Now we'll add a power indication LED to our power regulation circuit. So an LED has a positive terminal and a negative terminal. The positive terminal is the long pin, and the negative terminal is the short pin. The other way to indicate is the positive terminal has this thing, a projection here, and the negative terminal has a flat edge here. So this will be visible on the LED if you take a LED and hold it. Now, LED cannot directly handle current flowing through it, increased current flowing through it. It can only handle only a limited amount of current flowing through it. So to limit the current flow through the LED, we'll add a resistor in series. Series meaning which has the same line as the LED. The resistor will restrict the current flow through the circuit and protect the LED. So let's see how to add this. So here you can see that what we have done is from the 7805's output, the 5-volt output, we have taken a wire and given it to the bottom power rail. So the bottom power rail, the power rails at the bottom, the top rail in that will have 5-volt output. The bottom rail we connected to the bottom rail of the top side. So both of them are the negative. Now once we do that, we're going to need a LED and a resistor. So we'll first place the resistor between the positive 5-volt line and across one of these columns, and then we will take the LED and place the positive of the LED to this end of the resistor, and take the negative of the LED and place it on the negative line, the second row at the bottom, and then we can plug the battery in and you will see the LED glowing. This means that we are getting a stable 5-volt supply output. Next, we are going to build a very simple circuit. We are going to see how to use a push button and turn on a LED. This is an equivalent switch of pressing a switch and turning on a light. This is a very basic circuit. We are not going to make use of a push button in our robot anywhere. So this is just to get you familiar with how circuits work and what you can build with that. So a very simple circuit for that matters. So this is a push button. This is also called a tactile switch. So it has 4 legs. You can see A, B, C, D. You can see A and C are connected, B and D are connected. There is no connection between A and B, and there is no connection between C and D. When the switch is pressed, all of them get connected. A, D, B, C, everything is on the same line. So ideally we will have, like for example, we'll have a supply line. From the supply we'll have a resistor going to A, and then from D we will have connect the positive of a LED, and the negative of the LED will go to a ground. So when the switch is pressed, when the push button is pressed, the LED will glow. When it's released, the LED will not glow. These are some of the common mistakes which are made with the switch. So this connecting a switch like this, like between C and D or A and B, is a good circuit. So connecting between C and B is also okay. Connecting between B and D or A and C is not okay for a switch because they are already connected. Then it won't function like a switch. So ensure you don't make these mistakes when you're working with a switch. Let's see how to construct the circuitry now. So we need a switch, a LED and a resistor. So we know how we're going to place the switch in the middle. So 2 legs of the switch will come on this side of the breadboard, the prototyping area at the bottom, and 2 legs will be on the other side of the prototyping area. Once we do that, we can place a resistor from the positive side, similar to what we did for the power LED. Place a resistor once going to the 5-volt terminal, another one going to the one leg of the switch. Then place an LED, the positive of the LED to this end of the switch, and the negative of the LED going to the ground at the top. That is the negative rail at the top. Once you do this, plug in your battery and press the switch. You will see that the LED glows. This means your circuit is working fine. Next, we're going to be using a simple LDR. LDR is nothing but a light dependent resistor. That's a type of a resistor whose resistance will vary depending upon the light falling on top of it. Okay, when there is more light falling on top of this area is photoresistor. It's it's called, the LDR is also called a photoresistor. This is photosensitive material. So when there is light incident on it, the resistance of this LDR will go down. When it is in the dark, the resistance will be high. Okay, so most sensors are variable resistors. Most sensors, not all sensors, most sensors are variable resistance, meaning which their resistance will vary depending upon some physical property. In this case, it is light. We also have a thermistor, which is kind of a resistor whose resistance will vary depending upon heat. Then we have a bend sensor whose resistance will vary when we bend or when we keep it straight. Then we have a force sensor whose resistance will vary depending upon the force applied on this junction. So these are different types of sensors. There are a lot of other sensors, but most of them are variable resistors of some sort. Some of them are not variable resistors as well. So we are going to work with the LDR. We're going to build a very simple circuit, which is going to be like what to say, using the LDR as a resistor and see how the resistance varies. So to do that, we have the switch circuitry. So we're going to need a LDR and a LED. The LDR is going to act as a resistor. So we place the LDR between the positive 5-volt rail and one row on the prototyping area, and from that same one column in the prototyping area, from that same column we place the positive of another LED and the negative of the LED goes to the top ground rail. So now once we turn on the LED, you can see by default this LED is glowing because there is light incident upon the sensor here. So what we can do is, once we hide the sensor, the LDR here, you can see the LED is gone off. That's because in dark right now, since we are hiding the light, it has become dark for the LDR, meaning which the resistance is increased. When the resistance increase, the current flow through the LED comes down. So the LED is not glowing anymore. So this is how a basic LDR circuit works, but this is not how we are going to use it. This is just for you to get an understanding and familiarity with circuit construction. If you have noticed, we have constructed 3 circuits with resistors and LEDs all in a similar fashion. So you should be comfortable constructing a circuit with the resistor and the LED going forward. So let's go ahead. So here's a video on how the LDR works. You can see when the LDR is not getting light, the LED is going on. Sorry, the LED is going off, and when there is light on top of the LDR, the LED turns on. Next, we have voltage divider, which is a very simple circuit that takes in a large input voltage and converts it into a smaller voltage. It has 2 resistors, R1 and R2, and the the junction of this resistor produces an output when you measure, or is connected to the output. So the output or the voltage at this junction is less than the input voltage. So there is a formula on how this V out, what this V out will be for any given V in. You can see here V out to V in into R2 by R1 plus R2. So the circuit is commonly used with a lot of sensors which are variable resistors. This output voltage will then be used to trigger either a transistor or an operational amplifier. Now in our last circuit we had used the LDR directly as a resistor. Now we'll plug that into this voltage divider circuit and see how to use it as a basic sensor. So we'll use the V out to trigger a transistor. We'll see how it goes.